This is section 5.3 for pre-Cal 11, and we're dealing with coterminal angles. Basically, once we go past 360 degrees, we start doing more laps or more circles. It's a coterminal angle. The best way to describe it is if I have an angle that is, we'll say, 150 degrees, like so. If I have my radial arm, if I go all the way around and do a lap, I've done, well, if I go from, oh, this is going to make a mess. If I go from 0, so going from 0, I go up to 150, like so. If I go all the way around, I've gone 360. If I then go another 150, I'll be in the exact same place as 150 degrees. However, what I've gone is I've gone 150 plus that 360 degrees, which would give me an angle of 510 degrees, because they're in the same position. So 510 and 150 degrees are considered coterminal angles. Basically, it's how many laps you're going to do around this. Two things to note. In center position, whenever we go counterclockwise, we're always going to have a positive angle. If we ever go clockwise, we're going to have a negative angle. Whenever you're dealing with angles in center position, the same terminal arm, if you have an angle that goes more than 360 degrees, you will have coterminal angles. So we're going to take 70 degrees here. If I could do another lap, so I go from 0 to 70 degrees, if I kept going, I went 360 degrees and went back that additional 70 degrees, I would have an angle of, so 70 plus 360, I'm now at 430 degrees. If I did an additional lap and kept going, I would basically go 70 plus, I can go 2 times 360, and I'm going to get a total angle of 790 degrees, because I've done 2 laps plus that 70 degrees, so 360 twice, add 70. If I go backwards and reverse, because I know this is 70 degrees, but I know that if I go my negative angle, going from 0 back here, is going to be negative 290 degrees, because again, negative 360 plus 70 would be 290. If I kept going, I would go, well, there's 2 ways to do this. I could go 70 minus 360 minus 360 for a total new angle of negative 650. Or you could go, 290 then minus another 360, same thing. But basically, negative 290 and negative 650 are coterminal angles. So, sometimes you're going to be asked to determine or measure all the different angles in center position with a given range. In our case, you're going from 0 degrees to 1500 degrees that are coterminal, or they share the same arm as an angle of, in our case, 140 degrees in center position. So the first thing you want to do is you want to sketch out the angle you're given, 140 degrees. So we know that 0 to 90, 90 to 180, so we're going to be in quadrant 2, and 140 is approximately that angle there. like so. So we have our center position. Now we're basically going to count up and see how many more angles we can get until we basically max out or we go past 1500. So I'm going to go 140 degrees plus, if I do another circle, I'm going to add 360 degrees, which gives me, that's 500. So that's doing. And the real trick with this is just trying to keep it as neat as possible and well spaced. That's 500 degrees. I can go 140 degrees plus 2 times 360, or just 360 plus 360. That's about 860. Go 140 plus 3 times our 360 gives me 1,220 degrees, which if we then add another 360 to that will be past our 1500, so this is our last coterminal angle. So, all your coterminal angles are 500, 860, and 1,120. Sometimes you might be asked to write a formula for this, and basically what you do for your formula is you're going to say whatever number you're trying to deal with, so your initial standard angle, so we're going to say 140 degrees plus some variable, we'll say k, times basically 360 degrees, where k is the number of laps or rotations you do. Pretty standard. Sometimes you'll be asked about the principal angle. The principal angle is basically the least positive angle that is a coterminal angle within the given angles. So it's positive is the key point you want to take away from that. It has to be positive. And it's usually small, so it's going to be between 0 and 360 degrees. If it's not, if it's like 380, you can still go lower. And all you're really doing with this is you're either going to add or subtract depending if you have a negative or a positive number. If you have a positive number, you will be subtracting 360. If you have a negative number, you're basically adding 360 because you're thinking about which way around that circle you're going. So determine the principal angle for negative 753 degrees. We know that the principal angle is between 0 and 360. So when we have a positive number between 0 and 360, we can stop there. We're basically going to start with our negative 753 degrees, and we're going to add a positive lap around our circle. When I do that, I'm going to get negative 393. Again, that's not positive, so we're going to keep going. Negative 393 degrees plus 360 gives us negative 33 degrees. Again, not positive, so we're going to go negative 33. We're going to do one more lap around. We're going to add 360 to that, and we're going to get a positive 327 degrees. And that is our principal angle. Why is that useful? Because if you're given a huge angle like this, it's kind of hard to figure out what quadrant you're in. So if you're asked at the very beginning to determine the principal angle for this, and you're saying, well, what angle or what quadrant am I actually dealing with? Unless you want to start from 0 and count back, which is essentially what you are doing, 360 degrees so many times, we can find out that, oh, it's in fact, positive 327 degrees. So we're going to say, well, quadrant, that's in quadrant 3, and that's going to be about there, as that angle of 327 degrees. That's a little easier to graph than that, which is more useful later on. especially when you're asked to determine exact values, back from section 5.1. So, determine the exact value for the trigonometric ratios given an angle of negative 840. This is why the principal angle is important, because you have to be able to graph this and find out which standard position of angle you're dealing with. This is hard to do if you don't know a good angle. So what you're going to do with is find your principal angle first. So again, we're going to go negative 840, we're going to add 360, and we're going to keep doing this until we get a positive angle between 0 and 360. And once we have that, which we now realize is angle 240, we're then going to graph this. I know this is 90 degrees, 80 degrees, so it's going to be about here. And because we want to find the exact value, we want to know our exact triangle. So I want to find out what my angle right here is. So I can go, this is 180 degrees up here, so I can go 240 minus 180 degrees gives me 60 degrees. So I know that this here is in fact 60 degrees. And if I think back to my perfect triangles, with 60 degrees here, that means this will be root 3, this will be 2 is my hypotenuse, and my adjacent will be 1. So, again, dealing with exact values. We know that SOHCAHTOA, right, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Based on the 60 degrees, our sine of 60 degrees is going to be opposite over hypotenuse, so opposite over hypotenuse, so root 3 over 2, cos of 60 degrees is the adjacent divided by the hypotenuse, so it's going to be a half, and TOA is going to be tan 60, which is our opposite over the adjacent, so root 3 over 1, technically it's root 3, we'll go from there. You have to remember the cast rule, because some of these are positive negatives, and in fact, in our third quadrant, we know that tan is positive, which means cos and sine are negatives. Your very last step is to write this out, because it wants to know the exact value of negative 840, not 60 degrees. Even though we know that 60 degrees and negative 840 are the same thing. That doesn't matter. We want us to rewrite this. So we're going to say sine of negative 840 degrees equals negative root 3 over 2. That's one of our answers. We know that cos of negative 840 degrees equals negative 1/2. That's our second trig ratio. And our third trig ratio is tan of negative 840 degrees is the exact value of, it's technically just root 3, but it's not a bad idea to include over 1. And that is how you find our exact values when we have a degree that's bigger than, 360 degrees. And that's actually all there is for that. It's a lot of information. The nice thing is there is a lot more information on Google if you're still a bit confused. But the questions for this is I want you to find, for the angle 75 degrees, I want you to determine all the coterminal angles between 0 degrees and 1600. And I want you to give me the exact values of the 3 trig ratios for 390 degrees. If you have any questions, I will be available on Tuesday and Thursday for tutorial. Otherwise, good luck.